Ah, it's live, apparently. All right. Yeah, doing a room for no good reason again. Okay, it's dangerous. So if anybody wants to join the room, there's a. I can give you a link, but you have to ask for it for no good reason again, because trolls will be trolls and such. So you have to leave a comment in the comment section, wherever the hell that is, if you can see it or find it. Um, place a request there, and I will send you the link if you look like you deserve it. Yeah, whatever that would look like. Um, so anyway, I do have notes. Yeah, I'm a real physicist now, so I have a ton of stuff to go over and to calculate and to figure, and yeah, much to do. Um, so anyway, yeah, you just watch some of these, videos that are produced on physics, and they're just so bad. And they're just so dishonest in the sense that they're so incomplete in terms of prefacing any of their bold assertions about what's happening with anything like evidence, and that's sort of annoying. Yeah, really annoying. Um, so anyway, somebody did comment something about gravity and its speed. I don't remember the exact way they detected the speed of gravity. But I would think with all rockets and all that kind of stuff, they would have all this stuff figured out for some good reason. But yeah, the idea is that it's moving the speed of light. So hypothetically, yes, if the sun was to vanish in some sort of way, where it just vanishes instantaneously, stripped from its position, and the gravity just ceased, like this light from it. Yeah, it would be a little while before the Earth knew what happened. And was set free. Yes, it's a force. It's again. I guess the tricky part of that equation is um, yeah, the presence of the anti-force. Okay, the stuff that's making it possible for the Earth to move towards the sun is the fact that some portion of the sun's of the force going through the sun has been polarized, and that polarization, that excess polarization, has made it the force benign to half the force is benign to electrons, half the force is benign to protons, and through that mechanism has made it a weaker force on the one side of the Earth than the other side. And so yes, those tons would have still be traveling, and just like light, they would arrive here, whatever, 7 minutes later, and inform us that the sun no longer is continuing in its function, and that the Earth is free to go. And the Earth will go at the speed it's traveling at. um, yeah, um, without delay. I mean, it will regain just a linear velocity, a straight line velocity. It won't gain any velocity like in a roller coaster loop or in some other imposed mechanism of forced curvature where the object slows down and then speeds up when it leaves. The Earth wouldn't speed up, it would just be free to go. The same speed it's going now, the same orbital speed. Yeah. So, it's a good enough, interesting subject, I suppose. He also pointed out how the videos are long and blah, blah, blah. And yes, I have in the past made 1 hour style videos trying to just do the whole story from start to finish. And I suppose I'll do that again, but I really don't want to do it again until I do have some sort of graphics prepared for that presentation, and such. Um, yeah. But I really would like to be able to get a few more arguments. I'd like to be able to do that. Just have a regular opportunity to challenge different areas of physics. Have people challenge me with experiments that I might not be familiar with, and I would go find out something about them and come back in a couple of days and make the argument of why it's crap. It's always a good thing to do. I don't know why this searchy thing is on here. Get rid of that. Somebody must have hit something on the keyboard. Some asshole in this house. So no Ken Wheeler physics videos today, or yesterday, to pick on, to pick apart, to pick at. And I will, I have been doing searches on YouTube for relevant physics videos, but either they're just mathematical, subjects, just a lecture style, which I don't have too much opposition to, or it's kind of obscure subjects where it's not much to do with that. So anyway, it's better to have some sort of documentary to pick at, but it is surprising how few people make physics videos. I suppose, just considering there's so many people that are scientists, and it's just kind of funny how they don't really share much conversation about their science. There's very little chatter between scientists in any kind of open forum debating any aspect of their science. It just, you get a little bit of that, like I said, in a documentary or something, but other than that, there's very little, not for the show purpose, something that outside of a show, where there's any kind of real professional to professional kind of conversation. And it's just surprising that people are so undermotivated, or perhaps they're just too busy. I can certainly understand people being ground up by the the process of employment and maintaining your house and family and this, that, and the other thing, and you really don't have time to prepare for any kind of extra activity. But in opposition to that, there seems to be plenty of retired people and different people that should be interested in the subject and willing to exercise their years of experience and knowledge in some sort of participatory way. And there's just like none of that. And it's kind of like, there are retired people now that really should be, you could always make the excuse in the past that the learning curve of being computer literate was too high. But I don't think it's that big a problem now. Doing a YouTube room or something, this isn't too challenging in terms of computer skills and knowledge. Especially you can watch videos on how to do it almost. Maybe I should make instructional videos on how to hit the buttons. You move your mouse over the button and hit it. Which buttons to avoid. Don't be fooled by the button to nowhere. So, so it would be nice to be able to get an actual person, combative or not combative, whatever I don't really care for what kind of context it is, besides just being trollish. But it would be nice to have a sort of, for there to be some sort of opportunity to discuss physics in some sort of some sort of way that acknowledges What kind of evidence is being used to draw what kind of conclusions? And because none of these science videos really explain why all the physicists agree, or what it is that the conclusion that there's, I mean, it's in the physics girl video. She just says it. The electron's in more than one place at the same time. I don't even know if most physicists believe that. What they might believe is that they don't know where it is, but wherever it is, it's not in more than one place at the same time. They don't think that's happening. So I don't even know if they agree with what they're saying, and they're saying it so boldly, like this is the facts, this is the truth. We understand this. And I don't know, do they really understand it? Or are they just saying it because they think it sounds good to them for some reason? It makes sense to them in some way that electrons are in more than one place at the same time. Which, like I said, I don't even think physics believes this. And so, is that just she misspoke or she misinterpreted it? What? I don't know. It just seems pretty sloppy and clearly undocumented, and you have to just take their word for it, kind of a thing. And we shouldn't have to take their word for it. We should be able to get a taste for the quality of the evidence, not just be told that it is what it is. Again, it's sort of like that gravitational wave thing, where they decide ahead of time what kind of sound they're looking for, and then they happen to go through a billion sounds and say, yeah, we found it. There it is. It happened. That pattern means this thing that we predicted happened. Who knows? I mean, there's a thing called a mockingbird. There's things that can sound like something else, and they're not the thing they sound like. And it's where this gets really dicey. And when everybody talks like we've done it, and we've proven it, we've established it, it's the truth. And it's really not close enough to that yet. And somebody in their own profession should have the character to say they're moving way too fast, they're talking way too boldly, And like I said, from my perspective, it just became more obvious when you start picking at this thing and you find much better explanations for events, theories that have more explanatory depth, much more. And they don't even have a method for even considering those theories, listening to them, hearing them, judging them, weighing them, arguing them. Nothing. They're just completely deaf to that process. Substantially deaf. And so that's just the reality we live in. It's a very, very shabbily put together world, and a lot of stupid things going on, and the waste, just horrible amounts of waste, just merely because people aren't willing to have conversations about anything and to think about policy, and everybody's controlling turf, and what's in it for me, and shenanigans, and it's very bad, extremely troubling, disturbing. We can't have a better game than this. Like I said, even big picture stuff like the social policy arguments. Even if you were going to conclude that illegal aliens are a troublesome manifestation of poor policy, like you should be making citizens And if that's not the intent, then any policy should be modified to ensure that you are creating citizens, not just importing, um, people who aren't invested in your society or your civilization. Why would you import people who aren't invested in your future? That would be silly. And then if you want to have a policy that says, yes, we have to have a system and you have to have rules, um, again, it would be so much more sensible to stem the tide of illegal immigration by merely making it impractical for illegals to live here, work here. And that would be the easiest way to fix the problem. And you can fix that with rational policies like employer sanctions and stuff rather than building $1 trillion walls. I mean, it's just plain stupid. And I mean, it would almost appear that even if that was the policy chosen, the policy was chosen to be discouraging immigration, illegal immigration. There's so much better ways to discourage it than building walls, just hugely more efficient ways. And it's like the whole energy policy of investing in all this solar panel capitalism is not an efficient way to create solar. It's really good for little capitalist businesses, but it's not very good socially in the sense that you're paying twice as much for half as much. And that's, paying twice as much for half as much completely unnecessarily with no other real benefit is the definition of stupid. Just to make somebody rich, that's just stupid. It's really stupid. You compromise the welfare of millions of people to advance the special interest of 10 people, 20. That's really, really, really stupid, as is Heisenberg as a principle, or Huygens. So getting back to the physics, these premise arguments are just so, and like I say, it's never taken place. I mean, I've lived my whole life having a completely contrary to the establishment perception of what a photon was. So again, as a kid, I drew the conclusion, that I saw the period. I mean, I saw the electromagnetic spectrum. But yeah, that's an interesting subject too, just because that did come up in the ultraviolet catastrophe video. Because I thought about it and I said, well, yeah, there's a reason. Anyway, the point is that heat is one way to create photons, but there's other ways to create photons. So, naturally, in terms of process. So obviously heat's kind of a natural way that photons can be emitted. But when it comes to the high energy ones, they're usually produced by things that are radioactively decaying. So it's obviously a very different mechanism that creates the higher frequency photons on the electromagnetic scale. And then it's again another physical process that creates the stuff that we classify as radio waves. Heat doesn't create lots of radio emissions. So there's a different kind of vibrations, physical vibrations, in different areas of atoms that will create these different kinds of emissions. And again, in the case of decay, that's a very specialized in the sense that it has to do with the actual mass of the atomic structure and the fact that the element becomes unstable and is essentially, I guess in a way, is grinding, because of the number of electrons, they're grinding each other down, and that's producing your dust that become the tons. So anyway, but yeah, so my vision as a kid, I was taught this wave thing, and it didn't make any sense to me. And certainly it got very complicated very quickly when they, start doing the math of the two perpendicular waves. And it just, my brain sort of just glossed over. It's like, I couldn't come up with any kind of vision of a nothing that's doing two things at once in the first place. How does it even do that? And, just the idea of it, just this idea, you're turning it into this complex organism, a snake of some kind, or whatever, two-bellied snake. Room link for Michael. Very good. Let's see, where shall I post it to? Yeah, I guess I'll just post it in the room, and then I'll delete it. That's clever. Now, well, I better not give it to the trolls, just in case they're available for stealing and causing all kinds of hard trouble. Let's see, Pure Ho 314. I don't know. See, I don't know if your name indicates I should be giving you a link. There's a certain amount of trepidation I may feel at sending you a link. So I should be able. I'm going to PM you the link. I think if I can find the place where you can do that. That's funny. Yeah, well, don't be Skyping me. I can't put it in there. Awesome. I'll let him know. Okay, I got to figure out what you're doing over here in Skype. Skype isn't on the same computer. And so to post it to Skype, I have to basically email it to myself or put it in a file and then send it to another file that I can open. And that's not going to work. It's just weird. Report channel. I thought you could usually send a PM this way. That is really strange. I can't send a PM to your homepage? Quite bizarre. All right, then we have to come up with a different solution. Oh, what's this little bell thing mean? Maybe I'll try that. Notifications. Yeah. Send me all notifications for this channel. Now, I'm not terribly interested in notifications. Oh, that's really funny. Use magic dust and sprinkle the link here. Yeah, well, that I'm not doing either. I don't like magical things. Magical things make me nervous. I mean, you must have PMs turned off or something. Like nobody can send you a PM. You stinking hiding person. You're some kind of hiding person. All right, I'll try something else. We'll try some other method. All right, let's see. Use wave theory. No, I'm not doing that. I'm not using Huygens. Must be a way to do it right here. Let's see. Maybe if I hit this. No, I already hit moderator. Can't moderate you twice. Yeah, I guess you are like totally inaccessible to me for some dumbass, crazy, weird, fucktarded reason. Very strange. People cannot understand what you're talking about. I don't. Fuck you, Patrick. I mean, most people. Obviously, physics isn't for most people, is it? I mean, most people are kind of dumb. Not much you can do about that. All right, so Michael, I posted the link. Inform me when you have it. I posted it in the chat. I wish to delete it very quickly. So grab it and let me know when you have it. Simple to me for some dumbass.
Hey.
Okay, you have it. Okay, so let me delete my link. So
delete it from the room.
So the trolls can't get to it too easily.
How are you, Gary?
I'm about average.
So you're pretty good then.
Well, it doesn't get much better, unfortunately, than average. Well, whatever. Yeah, I guess you shouldn't even say average. I should say.
How come you can't Huygens me the link? Send it to Skype and Google Plus at the same time.
Yeah, I really have to work that out. But I mean, I have a Well, anyway, I've just never really connected the two devices, and so I really should.
Yeah, but if you Huygens it, it'll be in two places at the same time with some sort of quantum entanglement message.
Yeah, well, that's electrons. Electrons can be in two places at once, apparently.
Um, just while I'm doing some work here, I don't have a lot of time. I just wanted to say hello, but I'm actually, just as I'm working, I'm watching a BBC documentary called The Mystery of Quantum Physics, Albert Einstein's Nightmare. And I just watched them do the experiment of um, the catastrophe about ultraviolet light experiment. And I know you just recently did a video about the ultraviolet girl catastrophe. So I started to have a little bit of a look around on YouTube, but it's the same bullshit. Um, the experiment that they did in the BBC documentary, I'm sure you're familiar with it, and that's why I'm asking. They've got these two balls and they've got a little electric charge between it, and they're shining different coloured lights through it. And although I don't know a lot about it, I was hoping maybe you could perhaps talk a little bit about that experiment, the ultraviolet light.
Yeah, yeah. Sorry, that one I'm not familiar with. So yeah, I can't say
Really?
much about it. Yeah, yeah.
Okay.
I mean, I know they. I'm trying to think of what I have seen.
So yeah, well, while you're thinking, I'll just tell you what I saw. So when they before they got into the premise of quantum physics is whether particles or waves or photons or waves or particles. And in this experiment, they had two metal balls charged up, and of course, there's a spark gap. So what they did is they shone different types of coloured light between the spark gap. And what it seems to be saying is that ultraviolet light, when they shine it through the spark gap, allows for the spark to transmit across easier than different coloured wavelengths. That's their terminology. So they're using this as proof that it's a wave and not particles. And it's like, this doesn't prove anything. That doesn't prove it's a wave at all. It's just an experiment. And they're just saying, we made an experiment and it proves that it's waves. So
Yeah, yeah.
maybe,
Well, you see, that would go back to the whole ion argument. Like, ultraviolet light is more likely to produce ions. So, and it's the ions that allow the spark to jump across the atmosphere. So this is something that would only happen in an atmosphere. If they did it in a vacuum, okay, the
yeah.
experiment falls apart. So it's just the fact that the ultraviolet light is actually ionizing the gases in the atmosphere. I don't remember which ones, but it ionizes, I think, the oxygen and something else. And so
Mm-hmm.
it's creating the oxygen ions. And the oxygen ions are the things that are allowing the electrons to bounce essentially across the gap. So
Yeah,
so
yeah.
they're creating the pathway that the spark will travel on. So it's not exactly it's a magic trick that isn't really tricky. It's a pretty easy one to explain because I just did it. I mean, it's ions, right? I mean, ultraviolet light is famous for creating ions. So it's just, obviously that's the answer.
Yeah, well, they're they're getting from the end of that experiment. They're saying, well, this proves that it's a wave, and it's like, well, it doesn't prove anything. It could prove it's a wave, but without looking into it a little bit deeper, I mean, you've just given another explanation. My first thought was this has something to do with static electricity, but you're saying that the ultraviolet light is just breaking down the medium of oxygen between the spark gap and making it easier for the spark to jump across.
Well, I'm just saying they know you can just go by lightning theory. Okay, lightning theory. They sort of explain how lightning works, and it's traveling on the creation. It creates a roadway essentially first of ions. Okay,
Mm-hmm.
and that it's essentially creating a conductor, and then the electricity goes through the conductor. It creates a wire, and then the electricity goes blazing through the wire. Essentially, is what's happening. And it's a wire of ions, and then the
Yeah,
heat from the heat from the electricity creates even more ions, and that's why you usually have a second bolt of of lightning. It's actually there's actually when you see lightning, it isn't one thing of lightning. It's usually three
multiple
bursts of lightning that are actually going through the same path fundamentally. Like they'll spread out a little bit, but within whatever 1,000th of a second of each other, it's actually three charges of electricity that end up going through.
Yeah, when I started looking into tornadoes and weather about a year or so ago, I don't know how true this is, but they reckon just prior to a lightning bolt strike that there's an X-ray is supposed to come down and also create a roadway. So it's similar to what you're saying. Just before the bolt strikes, the X-ray creates a roadway which allows the electric charge to shoot down it. But I don't know how valid that is because I've read that on university websites.
Yeah, well, I'm just saying that you can sort of understand the idea of it anyway. It makes sort of sense that you end up with a this peaking idea, where the as the thing grows taller, the charge gets stronger. It grows taller because its charge is stronger. It grows taller because its charge is stronger. It's that kind of thing. It's very conducive to creating it's like the degrade of contacts on a relay. Like if you have ever seen like a high voltage relay, when it's controlling high amperages, that gets all kinds of little peaks and valleys, where it pulls metal off of the other piece, in the hot moments. And it's like those peaks, once they start to grow, they can grow and grow and grow, just because once they're a peak, then it's more conducive that they'll have deposits put on them again, and then another deposit will be put on them again, because the further out they go, the greater charge they end up carrying.
Okay, so they're just more...
It's sort of like a really slow feedback chain reaction. It's like a very slow chain reaction in the sense that the one thing guarantees that you're going to have a 10% higher chance of the same thing happening again. And then by every 10% chance, you just keep increasing your percentage of chance that the same thing will happen again. You know what I mean? Yeah,
it just becomes more beneficial for this.
Exactly.
Okay. I can't hang around too long, but I did want to ask, I would like to spend a bit of time here, but I just can't today. I was thinking about how you must have started to think about gravity and photons and quanta and all this sort of stuff that you're talking about. With relation to gravity, did you start thinking about gravity in the beginning? Because with gravity, that obviously your explanation of different polarizations, gravity obviously can't clump together, right?
Gravity.
Does that make sense?
Clump together.
So as a field, when you think of gravitons as a field, they must, when you keep saying that like polarizations would reflect off and they have to repel, gravity can't clump together. It would have to keep sliding past itself all the time.
Well, I know. I wasn't really worried about explaining where matter came from. So
no, gravity. When you first
I know. I don't understand the clumping part. Why would I think their light bulbs don't have clumps of photons? There's no clumps in magnetism. Why would I think gravity is clumpy?
What I'm trying to get at is, okay, so I was thinking about what you must have been thinking about when you started to come up with this concept. So my primary question is, when you first started thinking about this theory, were you thinking about gravity? How did you get to this?
Well, that was how it happened, though. Yeah, it started off with light, right? So I was thinking about the double slit experiment, and so I was thinking about tons and photons, and so then I was just trying to think about the different energies there are, and I thought about magnetism and electricity, and so I thought about gravity, and then so I just I ended up saying that I was looking for forces that could bend something or move something, and obviously gravity moves things like the Earth. You know what I'm saying? And so I'm just saying this is a moving force. So yeah, so I ended up thinking about it, and I guess there was something about it that made me. I mean, I just automatically just started doing this. What if it's push? How would I explain push? And then I just did the logical thing of saying, okay, well, what if there's a whole bunch of this stuff outside of the Earth? You know what I'm saying? And there's this field, like a magnetic field, and it's pushing stuff towards it. So I guess I was thinking in terms of a magnetic phenomenon at first, and then I just thought of, well, what if I just make the field, instead of it being created by the sun, the field's outside the sun? The energy is outside the sun, and the sun is just ends up being an incidental receiver of the consequence. You know what I mean? The force isn't in the sun, the force is outside the sun.
Yeah, the pressure all around it.
Yeah, and so then and then I said, well, wow, this fits and all this stuff, and I didn't find out much later. Somebody informed me, after I started talking about it, somebody informed me that there was this Lesage theory of gravity, and I was like, whoa, I didn't. Somebody already invented my shit, and then they said, oh, it's already been debunked, and I was like, well, okay, and then. Well, anyway, and so then I went through the process of having to deal with the fact that it does cause some problems with velocities and different things. And then I did the whole kinetic thing, and then I did the polarization thing to get around the problems created. You know what I'm saying? Once you just everything you create you create an explanation, and your explanation creates a problem with some other theory, and so then you have to explain why it fixes the other thing too, or why it changes it in the right way, not the wrong way.
Yeah, it's kind of, I mean, trying to understand what it is you're trying to impart's difficult too, because I mean, I've just asked you a question about clumping gravity. I only sort of started thinking about it last night, but it's like, it just raises, each question raises another 10 on its own. And it's like, man, I've got to try and think in a way that you think, and you have to try and understand what I'm trying to think. It's so hard because there's no book of grammar that you and I can use to share for a new language, right?
Yeah, and it is a little bit. It's not like it's really complicated, but it's got that edge to it, like chess or something, where you have to think a little bit 3 moves or 4 moves ahead, kind of thing, and that always gets a little bit messy when you're describing what you're thinking ahead of time. I mean, where you're heading, and and you have to have that kind of knowledge, because it's even when I say the force is heading right for you, you know what I mean? Yeah, well, you have to kind of understand that no, it's heading right for everything. Okay, but yeah, from every individual perspective, it's like a light bulb. It's all straight lines right for you. Everything that hits you looks like it's heading right for you. I mean, it looks all kind of almost like it's deliberately aimed at you. But no, that's just the way a random field works. The random field is pointed at every single spot in the field is experiencing the same syndrome of everything that will hit it looks like it was heading right for it for a billion years.
Yeah, and you've got like all conceivable angles and deflection points for this field. Something else, I think you made a video yesterday. You had a pen and you were saying if this is a photon, you've got to imagine it coming at you. But if you look at it from the side, it's not in even a dimension that you could detect or observe. So as with most of your videos, I'll have to rerun that one and have a look over it again. I think it was a good explanation, but unfortunately for me, I have to look at things multiple times for it to really sink in.
Yeah, it's just a
So
mass. It's just a way of understanding mass, and so when you think about it, mass can exist in this idea of there's 3 dimensions, and mass can exist in 1 dimension, like a photon. It's heading right for you. It doesn't do anything in any other dimension. And then theoretically, you could have 2 dimensions, like a galaxy, something flat that has properties in 2 dimensions. It has elements moving this way, and it has elements moving that way, so it has 2 of the dimensions, but not the 3rd dimension, and then you could have a 3-dimensional object like us, where we have mass, we have substance in all 3 dimensions.
Yeah, I'm going to make an obscure comment. So one of the things I thought about last night was with the Earth relative to the speed of photons traveling at the speed of light, actual Earth is moving at the speed of light, right?
Yeah, I mean, the stuff inside of it is. I mean, everything's moving the speed of light. Nothing can move any other speed, but that's the fish argument, right? Yes, obviously the fish are moving the speed of light. The school isn't, but the fish are.
Yeah, no, hang on. I understand what you're saying, but if you think about all of the external field to the Earth, right? If you, relative to them, they're not moving, but we're moving at the speed of light past them, right? Special relativity?
Well, I don't do relativity, so frankly, I think both the relativity theories are a pile of shit. So there's no
Is
such
it?
thing. Yeah, there's no such thing as relativity. We have an absolute velocity. Everything has an absolute velocity. Obviously, light has an absolute velocity that's the speed of light. And then the school of fish can only have an absolute velocity that might be the speed of light, but then all the fish in the school have to go exactly the same way. Okay, but as soon as a few fish are going some other way, then you're going slower than the speed of light. Okay, so it just depends on how many of your fish are going the wrong way. The more of your fish going the wrong way, the slower you're going. But everything's an absolute velocity, so there's no. I mean, quite obviously, all the light. I mean, all the force if it was perceiving other force, it would think it was going twice the speed of light, right? I mean, the force would be going, and it would be saying, oh, the light coming at it, it's going the speed of light, and the thing coming at it, it's going the speed of light. And obviously, those two entities would perceive the speed of light as being twice the speed of light.
Yeah, it's all a bit confusing, really. In fact,
But
I'd have to
obviously,
say,
they're not perceiving, is my argument, right? So they're not having a perception problem because they're not interacting in that form. So, it really doesn't matter.
Yeah, and it's getting off. Look, I thought of that one late last night, and it is irrelevant to what you're discussing. I mean,
well, I'm just saying the kinetic argument, it doesn't mean anything. It doesn't matter how fast the kinetic balls are traveling when they hit each other, in the sense that whatever one brings, it leaves with, and the other one leaves with whatever it brings, kind of an argument. You know what I'm saying? So it's always going to be, especially when it's an absolute. So even though when they're heading for each other, it looks like they're going twice the speed of light, to them, when they leave, they're going the speed of light.
Yeah. Okay. Listen, I'm really sorry. I'm going to have to go. But I'm glad you had a look at the physics girl, because I had a look at her a few months ago. Obviously, it's just more wave bullshit, but maybe you want to tackle the BBC documentary with that experiment. I'll just tell you the name of it, and if you've got some time to look at it. It's just called The Mystery of Quantum Physics, Albert Einstein's Nightmare, and the actual username account is called My Universe Documentaries. Goes for about 55 minutes, but yeah, it sounds like there's something in there that maybe you would like to have a look at when you get some time.
Yeah, well, like I said, I have critiqued some documentaries in the past, but we'll see if it hits the subjects that are important or not. But yeah.
Well, it talks about the argument between Einstein not agreeing with wave theory. Yeah. Anyway, look, I've got to run, but thanks for the quick chat, and maybe I'll see you in a couple of hours if you're still awake. I'll try and drop in again on you.
Yeah, well, I don't think I'll be here, but okay, you can try.
Yeah, no, that's all right.
Yeah, I
understand it's late.
I don't plan on being up all night tonight. But
maybe you can let one troll into the room and make something entertaining for me.
Yeah. Well, you have to pay me.
All right. See you, Gary.
Yeah.
Bye, mate.
Care. Okay. Let's see. Yeah. Well, I don't know if this pure hoe guy is worth the trouble here. A lot of typing, not much substance, I'm afraid. So anyway, that's, that was good. At least I did a little chatting on the subject of physics. So make it look like things are happening here, even though they're kind of stalled and stale. But, not much I can do. I can only keep forcing people to play. I can't force them. Oh, pure hoe pyro. Huh. Yeah, well, it's kind of a loose. Oh, yeah. Whatever. Good joke, I guess. I don't even know what the whole Piro thing is. He's just so ungrounded. I don't even remember why he uses pi in his screen name. When he doesn't seem to have a clue. Yeah, I saw your laser remark. I don't really believe you, but whatever. I don't think my theory makes me capable of making better lasers all of a sudden. I mean, there might be some theory there, but I haven't spent any time contemplating new and improved lasering. But it would be, it'd be cool to have like magnetic lasers. Yeah, I'll make a magnetic laser. That'll be cool. half light, half magnetism. That would be pretty neat. Well, maybe it's a good idea that I make lasers. Yes. Anyway. Yes, I really believe you that you're a CEO of a company and go around, bastardizing silly screen names with your CEO powers. Ah, Christian UFO researcher. Jesus is from, Alpha Centauri. No, I think Wajar is a pure idiot. By the government 99.9% pure standard. So, I think I'll get rid of you just for the fun of it. Yeah, this keeps me entertained. Ooh, that felt good. Yeah, little blocking is just, it's one of the few little pleasures you get on YouTube. Sorry about the smoking. I gotta, this, you can hear it all bubbling and boiling, and it's just terribly obnoxious. Win my Nobel Prize, I'll go back to smoking real cigarettes. I'll be worth it then. Yeah. So, let's see, is there really anything else I need to get over? I guess there probably isn't. I have to do some more preliminary work. Work on diagrams and images and whatnot. Some of the simple mathematics. But, yeah. Yeah. Tired. I'm evading the work. Tired of it. But must be done, so putting it off and procrastinating is just kind of stupid. I shouldn't do that. I just want to argue my way to the top. I don't really have to want to be a presenter. Yuck. So, I guess that'll be it. Yeah, there's no point in reading notes and contriving a subject and all of that kind of crap. Just figured I'd open the room, see if there was something available, looking for a fight. And apparently there isn't. So, since you know much about physics, can you give me a quick explanation about how cable TV basically works? Just give your opinion on or what you know. Well, it's so different than it was. I mean, the old cable, obviously, it had to run through a wire. Okay, the cable. It had to send a really complicated signal, like a radio signal. I mean, high frequency, lots of information had to be contained in it. And, obviously it's streaming, it was streaming broadcast channels, many of them, many FM signals through the wire for each one of the broadcast stations. So that's why it was a coaxial cable, is because the shielding isn't really to keep noise out. It's it's really to keep noise, the thing from becoming a giant radio transmitter. Well, partially. But yeah, that's basically what it's doing, is it's just taking what would be radio signals and it's sending them through the wire instead, and it has to send them at different phases so they don't bleed on each other. And then the cable box would basically just convert all those different radio frequencies, would pull it out of the one signal, and hopefully it would not be all screwed up. But the fiber optic thing is, changed the game, in terms of, how they send it. It's kind of, the signals are more individual and they just send them on different paths through the cable. So it's like if you took the round circumference of the cable, they're basically bouncing the signal off the inside of the cable. So they can bounce it at all slightly different angles. So they can have a whole bunch of signals in that 360 degrees of the circle in terms of just changing the angle a little bit of where it bounces. So each signal is bouncing off a different exact point through the cable. So they're all bouncing off different angles, and so they don't interfere with each other as much. So they can receive the signal at the other end. Each one will be coming in at a different angle, the light. So they just pick up the different angled signals instead of, so it's a little different. At least that's what I think they're doing. They might be doing something else now, but that's how it started off, was that the great thing about fiber was that you could put a whole bunch of signals through at different angles. But what is the signal composed of? What subatomic substance? Well, obviously in a metallic cable, obviously when you convert it into light, it's light. So fiber optics is light. But in a metal conductor, it's just like a 12-volt voltage, like your phone. It's just sending the signal through an electric current that's being amplitude modulated. But I think they're using FM, so it's actually frequency modulated. But it's the same thing as a radio signal. It's just that it's not being broadcast. It's being sent through the wire, but it's a current. It's an actual electrical current that it's composed of. So it's composed of, the tricky part is explaining what electricity is. And I guess my argument about electricity would be that it's more complicated than just moving electrons. It's the field energy between the electrons. So it's really a stream of field energy that moves, and the electrons just kind of roll with it. So the electrons are they're just floating in the field energy, I would argue, because the real energy is going through the electrons. It spends some time in the electrons, but it doesn't stay in the electrons. And so it's moving much faster than the electrons are moving, because it's really just moving the magnetic connections between the electrons, and those connections are made out of this field energy. So it's quanta that's moving down the wire. The form it's in is kind of, I guess you could argue that it's a kind of gravity, or it's a kind of magnetism. That's what electricity is. Electricity is sort of in between gravity and magnetism, to answer the question. That's how I would describe it anyway. But what is frequency modulation? Well, we already did that subject, but I'll do it a little again. Look, AM, amplitude modulation, just means to make a variety in your signal. Like if I say hello, that would go like hello. It'd have a look to it, and you do it by amplitude. Okay, so the more photons you shoot, that means the thing goes up, and the less you shoot, it goes to 0. So you're making a pattern based on how many photons are shot, and that'll decide the amplitude. And then the frequency modulation just means that you send the same amount at, and what you're regulating is how often you send them. So you're sending them at different periods. So you send a burst like a digital signal. Okay, it's on, and it's on for whatever, a little bit, and then you go off, and then you go nothing, and then you go on, and you go off, and then you go on, and then you have an interpreter that can tell what that means. That basically is a code for the word hello, based on a standard created for how to describe it, a standard, like an MP3 file, or there's an algorithm that'll tell you what each one of those kinds of distances, what kind of sound that represents. So a different distance represents a different sound, kind of a thing. Yeah, it's not the best way to explain it, but yeah, so FM is sort of a digital kind of signal, and AM is kind of an analog signal, kind of. I mean, FM would look like a pattern that would be very the same-ish, just a bunch of jiggly lines in the same height. And AM would be doing this thing, lots of fluctuations and ups and downs, and little ups and downs, big up and down, that kind of thing. Let's see. How are they doing the manipulation? Well, the manipulation is through the microphone. It turns the signal into an electrical signal. So as it gets hit, it's creating your AM kind of signal. And then you just use another converter to change the AM signal into a FM signal. Well, microprocessors are really just a bunch of on-off switches. So a transistor just basically does a simple thing. You put a little tiny current in, and it allows a big current to go by. So you have a lot of current that wants to get through a little gate, and then it has an open thing here, and you basically just have a little current that opens and closes the gate. So it opens the gate, the current could go through, closes the gate, current stops. So you can use it for two purposes. You can use it to regulate how much stuff goes through, or in microprocessors, you can just basically use it as an on-off switch. And so an on-off switch is basically when you hear about bit code, like, bit math, where it's like the ones and the zeros, right? And the ones and the 8-bit would be, 8 ones and zeros. And based on the 256 possible combinations of ones and zeros, you can make 250 different things. And so you just make each code means a different thing. So they can mean letters. And then once you make them make letters like A, B, C, D, E, F, G, and then you have capital letters. So the 250 would obviously cover all the alphabet. Then you can spell words with those on-off signals. So what a microprocessor is doing is the on-off switches are basically in registers of 8, okay, for 8-bit. Obviously we're up to 64-bit, so the numbers have gotten really big. But the old ones, it'd be these 8-bit blocks, and you'd have 8 switches, and those 8 switches, based on whether they were on and off, would indicate what's in that location. And so you'd have a letter in a location, and you'd have a whole bunch of these registers, and and then all the registers be connected to each other. So when one bit changes in this register, that causes a cascade of changes in all the other registers and that kind of thing. But they're just basically on-off switches that are representing states of on and off, and then you just use a matrix of switches to represent concepts like the number 2 or the letter A. think that's an explanation. I think that's good enough. I'll have to do. How do diodes work? It is a repeating bumper on a surface, making it all vibrate. How to, oh, dildos. Yeah, the DraftScience guy. Anyway. Yeah, well, that's just useless. I'm not really going to answer the dildo questions. No. So we'll just say goodnight to DraftScience. Nasty people. Doing little nasty things. So rude. Yeah, it was kind of when I was working in electronics is when the first microprocessors were created. It was kind of funny. It was we used, I used to do the circuit boards, for controlling devices for, robotic industry machines and such. And and all our circuits kind of had to be made out of transistors and capacitors, and you had to, there was no thinking part. You had to create any kind of thinking part. And then when things started going digital, first the motors went digital, so you could move motors, little tiny bits at a time, in each direction by putting a positive or negative current. You could, and then, the microprocessors fit right in with that in the sense that you can control the digital signals, with the microprocessors. And so, but yeah, that was like, it's sort of interesting because I grew up through that period of transition from, circuits that were completely, that didn't do any thinking, to circuits that did thinking, logic circuits, I guess what you'd say. I mean, the logic circuits that you made out of transistors and stuff were so simple because you obviously just didn't have the real estate on a circuit board to, try to create a computer out of transistors. But yeah, it became quite different when you had a simple device where you could just put in, 3 signals, and this would detect whether the machine was, lined up straight, or, would check different sensors, and then you would get an output, and you didn't have to do any, you didn't have to create that logic circuit out of anything. You could just have it go into the little computer chip, and the little computer chip would pop out the right answer. I don't understand how they are manipulating the material that makes up the processor. Well, it's I don't know whether you're talking about the silicone itself. So that's the material, and all it really is 3 layers. Well, now they're more complicated now. Obviously, it's gotten much more complicated. But the idea is just 3 layers, and so your top layer would be your positive, the bottom layer would be your negative, and you'd have the semiconductor in between, so to speak, and that's the on-off switch. And so depending on how deeply you bore into those surfaces would mean you could create different devices, like a resistor or something else. You could synthesize different components depending on how deep you went into the material. All right, but really the signal is a manipulation of an electrical charge. Electricity is a component in physics, but when they refer to a signal, they are suggesting that the electricity's features have changed. Now, the electricity doesn't change any. Again, you're just putting a frequency on it. You're just changing its, you're putting a pattern into it, and then you're matching patterns. And when the patterns match, a certain thing happens. When the patterns don't match, a certain thing happens. It's just all kind of cause and effect. So it's sort of a Rube Goldberg, thing where you just set it up where, one thing cascades into another thing. If certain switches are open, this is what will happen. Certain gates are open, things will go through the gate. And, I don't know how to I mean, it's logic circuits. I mean, it's, you know, you kind of have to know something about programming, I guess, to kind of understand that. But it's just gates. It's just open and close doors. Yeah, it changes the amount that goes through, and you know, obviously that can be used in a lot of different ways where you can add voltages. So if you have 2 volts coming from one place and 3 volts from somewhere else, you get 5 volts. And if it's 5 volts, it hits it triggers the byproduct. I mean, it's just cause and effect kind of things. You're just setting up a bunch of traps. And if the conditions are matched, then the trap springs. So it's like a bunch of mouse traps or something, and they're set to different things depending on the conditions you're trying to measure. Yeah, exactly. If then, else, you know. A lot of it then situations. A lot of, yes, right. A lot of if then. While this, you know, whatever, however you want to phrase it, it's all the same thing. If this, go to that. That was one of my favorite bits of, I mean, that's the real old assembly code, was really just kind of that kind of thing. You just were bouncing from register to register. So you're just basically going from memory location to memory location. So what you're basically just doing is going from the simple 8-bit instruction kind of thing, and bouncing from one, each box would just contain another location to go to. So you would just be like going from one location to another location, because the next location would give you 6 things to do. And then you do those 6 things, and then you bounce to another location, do 6 things, and then you bounce to another location, do 6 things. You know, it's just a lot of go to. If go to, that was, yeah. What happens to the excess electrons? The board doesn't use all the charge coming from the outlet. It just converts to heat radiation. Well, yeah, it's really not, there's no such thing as not using. So there's either a path or not a path. There's no such thing as, you know, there's a path or not a path. And even a problem with transistors is, you know, it gets a little dicey. The more it's like dimmer switches for light bulbs. The more you use the dimmer, you know, the more you're suppressing the electrical flow, the hotter the thing is likely to get, and the more likely it is to burn up. So if you're just dimming the lights a little bit, you'll be okay. But if you dim the lights a lot, then it gets even hotter, which is not intuitive. But that's sort of the game. So yeah, there's an imperfection in the way it's creating an obstruction. So resistance is almost always going to create some kind of heat. It's very hard to create a perfect resistor that can suppress a percentage of an electric charge or current, you know, without ending up with heat. I don't know if Ohm's law really cares about heat. It just cares about the you know, a certain amount of resistance will work for a certain amount of current. Yeah. So it's tricky. I don't know if Ohm's law really doesn't cover the thermal properties. Are kind of like, like if NASA was making a resistor, they could make a resistor that's made so well, the tolerances are so perfect that the heat doesn't make the thing more resistive or less resistive. So the problem is with common circuits is that as they got hotter, the resistance would change, which is really bad, you know, because then your calculations go everything goes sideways because now it's not doing what you thought it was doing. Its resistance is essentially changing because it's getting hot. And so that was one of the big liabilities of making a complex circuit, was that as it heated up, the resistance of all the resistors is starting to change, and then everything starts to go all fucking sideways. And your signals end up bleeding into each other, and all kinds of stuff you didn't anticipate happens. So it was hard to make. Some circuits were just too, you had too many, you were trying to cram too much stuff into too tight a space, and you'd end up with all kinds of signal leakage, between the components. And like I said, it would work on paper, but it wouldn't work in practice because you just couldn't isolate things from the heat of some other. Like I said, one component's creating heat, and it's just starting to fuck the tolerances of your capacitors. Now your capacitors aren't really what they used to be because now they're hot. Yeah, it really was hard to diagnose. I remember, the guy I worked for was pretty smart, but every now and then you'd have to have a college graduate type guy, come in and do some consulting work, because we'd end up with some sort of circuit that, like I said, it worked on paper, but something was going wrong, and it was just so hard to figure out what component was fucking the game. Yeah, I mean, heat really is the whole idea of it is kind of interesting in how everything runs on it in a sense. I mean, the fluidity of everything that's happening is only happening because everything has got the grease of heat in it. So if it wasn't for heat, you couldn't do anything. Nothing would move very well. Um, but it's also, so hard to control the amount of that radiation that's inside of your circuits. So yeah, I don't remember all of my electronics knowledge, unfortunately. But yeah, I used to know. I used to be able to read the codes on everything and do all that crap, and I don't remember any of that shit. Let's see. The atoms have more energy, and spacing of the subatomic particles increases, and the amount also increases, and some creates more friction with other molecule particles. Well, I think you can just think of it as that everything's being bounced around more. Everything's in a cushion of activity. So in a way, like I said, you can almost think of it as a lubricant. Heat is almost lubricating the bits, and so it's almost easier to pull them apart just because you've lubricated them, in a way. So yeah, it's maybe not the best way to think of it, but it's sort of like that. It fills everything with air, and now everything can move around much easier. And such. Let's see, the gravitational forces holding the particles are working harder because the particles have been energized. Yeah, well, it's more like the gravitational forces that have been converted into magnetism. So you have to kind of understand that the stuff holding atoms together, the electrons and the protons, is magnetism. So it's polarized gravity technically, but so it's better to think of it as magnetism. So they have more momentum. Is that correct? Yeah, yeah, not really. Um, so you have to kind of think of it as they move in one direction and then they move back and they move and they move back and so whatever acceleration they have, they give it back. They decelerate in the opposite direction. So they're really jiggling, and jiggling is a little bit different than a linear velocity. So it's like they don't do any real accelerating in a sense because they don't maintain the acceleration. They don't convert it into um, an actual. Let's see, what's the best way to put that? Hmm. I guess the equilibrium part is the only part that matters. I mean, if you go left and then you go right, you basically undo whatever you did to go left. You basically undo it to go right. So whatever events took place when you went left, that is whatever you excreted, you probably absorbed exactly the opposite thing to go back the other way. So it's just that you just end up back at an equilibrium state, but the process itself just means that for you to be jiggling means that there has to be force around you that's uneven, that keeps changing. So it's that field energy that's creating the energy. And I mean, the electrons are a symptom of the field energy in a sense. So it's like the, chicken egg thing, like which one comes first? Well, in a sense, you know, the acceleration is causing an excretion by the electrons. But again, when you accelerate in the opposite direction, the excretion is in reverse. So you're absorbing. So you just keep spitting and then, well, in a disgusting manner, you suck up your own spit. I don't know how to say this without getting a little bit messy. Um, there's parts of it that aren't that are conservative, where you're going to consume what you've produced, and then there's the part of it that is destructive in the sense that you will permanently radiate heat. But to permanently radiate heat, or to radiate heat, to give away heat, then you have to actually have heat come in some other form, like electricity, or you have to have force come in some other form. So the force has to come in through light or through electricity or through some other mechanism, and then you excrete it as heat. Um, or you burn your matter. You radiate like a radioactive isotope or something. And you what's the word for that? you um, decay. Yeah. Yeah, well, it's probably like something like that, you shithead. But yes, it's like something disgusting. Yeah, and, yeah. Some asshole's been fucking with me here. Yeah, I wasn't paying attention. I guess I got muted. Yeah, I didn't rage quit. Somebody fucked with the room, and then I got kicked out of it and they turned my camera off too. I don't know how they did that. Fucking cunts. So anyway, yeah, I'm back in the rooms. I don't know about you fuckheads, but anyway, now I'll stop the broadcast now anyway. Oh, you're saying, oh, cool. Good night, everyone. Oh, cool. Yeah, I don't know. Yeah, whatever. So am I back? Hello, can you hear me? Testing. I guess you can. But anyway, yeah, I probably should go anyway because it's just, I don't know. It's just that I don't recall that particular thing happening before where, but it might have just been a glitch of some kind. But it's like strange. The window just completely turned off and went dead. And then, but it must have been a thing Google did because Google reloaded it for, I didn't hit anything. I mean, I didn't touch anything. And, it just happened. It went off by itself and then it went back on by itself. So at least that was interesting. I didn't have to do anything. So anyway, it's probably a sign from the quantum entanglement that I've overstayed my welcome. It seems difficult to describe. The forces holding the particles together are effectively in their ability to hold and stay near the nucleus because of what? It seems difficult to describe. The forces holding the particles together. Well, okay, you got to remember that, okay, number one, there aren't really, the force is just the part that's doing stuff is only this, the color again, the suit of clothes, the hat. So the quanta wearing a hat are the ones that can fuck you up because you'll react differently if the quanta is wearing a hat and if it's not wearing a hat. So that's sort of how you have to think of the force. The force is always there. There's always stuff moving. You never change the fact that stuff is going in directions. So nothing, the momentum never really changes. The only thing you're doing is exchanging the hat. So the guy who, you're passing somebody on the street and it's like it's a hot potato or it's stolen goods or it's a guy's wallet or and the cops are after you and you just like throw it in somebody else's car. It's like you're just exchanging the hat. And so now the hat was going this way down the highway and I throw the hat over that way and now the hat's going the opposite direction. And then that guy throws the hat and it's going some other direction. And that guy throws the hat and it's going another direction. So you have to sort of think that when you think about the force, that you're never really creating more or less force. You're only you're only changing whether the things in the force, whether the crowd is wearing hats or not. So it's like if you were a building and you stored, let's say you're a building on Times Square, and over time you've collected a bunch of hats. Okay, you got a bunch of little people with hats on. And they're, obviously I'm saying the forces keeps changing, but the hats are staying where they are. So in a sense, they're doing the little square thing. You know what I mean? Every time somebody's going this way, the next guy gets the hat, goes this way, the next guy goes this way, the next guy goes this way. It always turns out the same. So they're all kind of stuck in your building going around in circles with these hats on. And then, there's people going past your building on Times Square, and what you're essentially doing when you're creating electricity or creating something is you're taking the hats and putting them on the people going down the street. And now your guys that had the hats, they go away. Okay, you lose those. But what you really did is exchange momentum. You just exchanged which momentum is wearing the hat, the one in the building or the one on the street. Something like that. But it's just follow the hat. I'll have to come up with some kind of way to describe this, but that's the weird thing, is that this really isn't about, I mean, in a sense, I made a joke about light. When you have the light off, there's no field of light anymore. But technically there is. There's still stuff flying the same exact route that the light was taking. Just that it's not wearing hats anymore. It's all hatless. Yeah, I don't know what's going on. I have a fiber optic connection, but who knows? Weird. I didn't see it blip out, but if you say it did, it did. So basically, what are all the particles that you deal with when describing these phenomenon? Ions, neutrons, electrons. No, they're not particles. They're schools of particles. Neutrons, electrons, protons have perhaps a million or more quanta in them with hats. Lots of hats inside of an electron. Lots and lots. Identify the atomic particles and the subatomic particles. Like I said, there's only the only particles, the only indivisible elements are the quanta, and they can be in the form of gravity, they can be in the form of magnetons or photons. They move in a straight line at the speed of light, and that's all they do. And they're either doing the gravity thing, the magnetic thing, which is wearing a hat. The gravity's not wearing a hat. Magnetism's wearing a hat. And then light is wearing a hat at a frequency. You know, so each guy is this exact amount of distance away from the next guy wearing a hat. But that's the forms of the elemental elements. Everything else is just a collection of hats. Yeah. Well, I'm sorry it doesn't make sense to you. I guess you're just too stupid to understand. You know, you're bad, not mine. But then space does make sense to you, apparently. Does Huygens make sense to you? Does it make sense to you that there's a principle that's only used in one circumstance? And that principle says that every time a wave is created, that an infinite number of little waves are made in front of it, and that they create the next wave front? Does that make sense to you? Dumb cunt? Oh, it does. It makes a little sense to you to have a principle you only use in one circumstance and call it a principle. That's hilarious. But anyway, and bent space, nothing tells something what to do. That makes sense to you. Yes, nothing is always telling the something what to do. It's just very irritating. And pull makes more sense to you than push. Like it's so easy to, if you had to create something that had to push, or you had to create something that pulled, it would be so much easier to make a pulling thing, right, than a pushing thing. Well, no point in saying nothing is nothing. But whatever. Stupid is stupid types. Well, obviously, part of everything is the word nothing, so everything can't be something. So you're kind of logically wrong. Ha ha. Yeah, well, it seems, like I said, I can't even make sense out of the whole mechanism of transmission. I mean, I can understand bullets flying through space. I can't understand a wave that doesn't spread. Okay, that's what do you mean? A lump. Yeah, a lumpy thing, just a little lump. Just doesn't do it. Just little lump moving the speed of light. Yeah, that's pretty hard to understand. So yeah, I get the idea of bullet. I don't get the idea of wavy lump thing. Aren't you a racist anyway and a fascist? Well, whatever. I don't think I need to bother with you any longer. Oh, I think yeah, oh yeah, I did block him. Okay. Didn't know what button I hit for a minute there. Yeah, anyway. Well, certainly when they start talking about superposition and they start talking about electrons being in more than one place at the same time, that doesn't sound right to me. But even bent space, like I said, I couldn't put my brain around bent space at all. I mean, just I'm just saying, something has to be bent. You can't bend nothing. You got to be bending something. So what are you saying? There's an ether. Okay, so I said, okay, there's an ether, and they're bending the ether somehow. Okay, but like I said, and then as soon as you three-dimensionalize that, this bending shit ain't gonna work in 3 dimensions. I mean, bending is fine for this little 2-dimensional toy you're making, but how do you bend something in 3 dimensions? That just doesn't work at all. That's not bending anymore. That's sucking. You have to be able to suck all the space. Then you're contracting it. You're creating a convergence. It's not a bend anymore. It's not bent space. It's converged space. That's a lot harder to explain because then you have to sort of explain where it's all this vacuum cleaner. Where the hell's the outlet? Did you just say electrons, neutrons, protons? I don't know. Did I? I don't know. I don't know in what context. I mean, obviously they're the elements of an atom, but look, again, they're not particles. They're a collection of quanta of wearing different hats. The electrons have blue hats, the protons have red hats, and the neutrons have a mixture of red and blue hats on their quanta. And their quanta are constantly changing who's wearing the hat. Every zillionth of a second, who's wearing the hat changes. 1 minute the hat's going that way, and the next second it's going that way, and the next second it's going that way, and then it's going that way, and then it's going this way, and it's going that way. And when you add it all up, it ends up being kind of a circle. That's why it stays where it is, because it can't get out. It goes this way, and it hits something, knocks it down this way, and then it goes that way, and it hits something, knocks it back this way. So it's just doing this kind of stuff all day long. The hat just keeps going back and forth and back and forth and back and forth. But it's actually riding newtons. So it's getting a new carrier all the time. But the hat itself just can't get out of the building. So, I'll have to come up with a more perfect metaphor than clothes and a hat, I suppose. But it does sort of, I can see it that way. But I realize other people, maybe they can't. But it's like there's lots of activity under the hat, lots of stuff happening, lots of exchanges, but the hat isn't really going anywhere. The hat's a representation of polarization, so it's a representation of the fact that the quanta is a frisbee flying this way or it's a frisbee flying that way. But I'm just trying to make that more visual. To understand that certain polarizations are what are collected inside of the things we call electrons and protons. So they're a collection of one polarization. And those polarizations mean that they're susceptible to interaction with things of a different polarization and the same polarization. They'll behave differently. And so we're back to this simple kinetic diagram, which I should have available for display purposes here. Oh, where the hell did I put it? I use it all the time. Where do I put my most famous drawing of all time? Most useful and productive and explanatory. But you see, in kinetics, if same thing, same color hits same color, the universe looks exactly the same. So if you thought of this going this way, it looks exactly the same as if it went straight through or if it didn't. So it all looks the same. The universe doesn't change. But if their polarization is opposite or different and it reflects, then you can see that the universe changes, because then the polarization is moving in a different direction. So polarization goes in one way, polarization leaves a new way. And clearly that becomes obvious here, where the red polarization had momentum in this direction, and now the red polarization has momentum in the opposite direction. That's a huge difference from this kind of scenario. And that's what I'm attempting to describe as the hat thing. Okay, the difference is that when you're wearing different hats, you will interact quite differently in the world. So you'll mean something differently if you're wearing a hat. It's like having an ID. You can get into the club if you have an ID. If you don't have an ID, you can't get in. That's how things are getting filtered by polarization. Polarization enables there to be change because it's change can be identified, where without polarization you couldn't identify any changes. I mean, it's a simple argument to say that it's like I said, you can visually see it, but it's obviously got more of a meaning mechanically than just this visual argument. Well, that's, you're not Miles anything. Mills Mitchus. I don't know what that is, but you're obviously a retard. But yeah, no, there's no relative polarization. So there's different polarizations, but they don't have a relative component of any meaning. Except that there's, just like velocity, there's velocity in a direction, and then there's a perpendicular velocity, and that there's two perpendicular dimensions to every dimension. So every dimension has two perpendicular dimensions, to it. And yes, that's all significant, but I'm just saying that's the kind of minutiae you don't need to get into to understand the mechanics. I mean, no point in trying to have there's little point in trying to visualize it in 3 dimensions, because you're just, I don't think your brain can do it. I mean, I just don't think it's practical for us to try to do that 3-dimensional chess thing or something. I just don't think our brains are complex enough to be able to handle a model that complicated. So to imagine it in 3 dimensions, just, you're just going to hurt yourself. So it's just easier to imagine it in colors. Just say that you acknowledge the fact that for the purpose of the relationship between 2 things, the relationship can always be drawn in 2 dimensions. So just deal with the 2 dimensions, and that's going to be good enough for most applications. When gamma rays are applied to magnets, gravity changes around it. I don't know. Prove it. Ken is right. I have proven a photomagnetic effect in my lab in New York University. Well, says you. So I don't, fine. Gamma rays are, quite energetic, obviously, and you could almost argue that maybe X-rays would fuck up a magnet. I don't have a theory on that personally, but I can imagine that anything that's going to make the domains liquid, movable, is going to change the capacity of the magnet to manifest its magnetism, to convert gravity into magnetism. That's what it's doing. So obviously gamma rays, any kind of, I don't know how much, I mean, obviously you'd have to have a source that's actually energetic enough, or a magnet that's small enough. But fine. I mean, it'd be very, if you can prove it, fine. I don't know what that demonstrates. I'm just saying, do you think that proves there's ether? I don't think that proves ether. That applying energy to a magnet. Obviously, we already know that if I apply heat, just something as simple as heat to a magnet, I can fuck a magnet up. So if I make a magnet hot enough, it's not a magnet anymore. So I'm just saying, I don't know what you think it means. It's not physical. It's a computer modeling software. Well, that's even sillier. So sorry, I don't really have, I have zero confidence that you can model the atomic structure of a neodymium magnet adequately in your software and then expose it to radiation in your software and have a model of the reality. I don't think there's any chance in hell you can do that properly. Now it seems to be getting over a bit of chemistry. I don't know what that means, but okay. It's all in my software. The math proves it. Well, again, you're just wasting my time. So good night, Gracie, our silly person, our stupid fuck. yeah, right. I'm really jealous. Make a YouTube video. I love watching videos. Anyway, here's my model of the interaction of gamma rays and exposed to. Yeah, I don't think so. I mean, so many. I mean, it's a really good science. And, modeling software is a great asset to a lot of things, but it's really difficult. I mean, obviously, being able to account for all the quanta interactions, the minutia of the interior of an atom, we just don't know enough about that mechanics to be able to punch it into a computer program and say, this is what's going to happen. So it's only for like kind of large scale, kind of big picture, kind of blurry ideas of shit. But as soon as you get into any kind of detail, you're going to really run into trouble with a computer model. Quanta, which can be called gamma radiation, well, yeah, it can be called any kind of force. So anything, light would be a force, all radiations would be a force. So it's all quanta. It just has obviously, to be on the electromagnetic spectrum, it doesn't have any electromagnetic quality. It just has this idea of polarization and frequency. So it's a certain polarization at a consistent frequency. Can you describe the properties and dynamics of that? Yeah, well, again, the properties are the frequency. And as I pointed out earlier, it is kind of curious that even though the electromagnetic spectrum is drawn as if it's a nice balanced curve, it really isn't. The radio waves are caused by a specific kind of manipulation of atoms. That is, almost in a sense, you're vibrating the entire atom and shaking shit loose. The middle section where visible light ends up being is really heat related, substantially. Heat is the easiest way to generate light. And, the higher end, X-rays and above, usually the only sources of those things are going to be radioactive elements that are decaying. So that's a specific kind of brokenness. So you can't really create X-rays by generating heat. You have to, you have to, you have to, yeah, you kind of have to use a different mechanism to create that higher frequency. So that means you're shaking stuff loose in a different manner. That's why it has a tighter frequency. But the frequency would be based on an argument I was making before about the electrons and the bits inside going back and forth. And I described it as a square in the end, but it's really stuff going back and forth at all different angles. But it's really that distance that is the frequency that probably is the radiation. So electrons can produce infrared easily because that's the most abundant distance they're separated by. And to create shorter frequencies means it has to be a more compressed electron. So it has to be under higher pressure to create the shorter frequencies. So the electron would be compressed. If it's in a compressed field, and you could sort of imagine that in a big giant atom where there's a whole bunch of electrons, they're probably more compressed, being squeezed in, and that's why they're uncomfortable. And it would only be in those electrons that you would be able to create that high frequency, because when you let something go, it's going at a much higher bounce rate inside the electron. So inside the electron, it's a higher bounce rate. And then for the most common state of an electron, there's this kind of bounce rate. And like I said, radio waves are almost a more physical ejection of frequency. So you're not depending on the frequency inside the electron to create a radio wave. You're really just letting quanta go. So you're almost letting gravity go. You're almost pushing gravity and then pushing another hunk of gravity, but it's polarized because it came out of the electron. So don't get me wrong. It's not that it's not coming out of electrons, but it has the right polarization, but you're almost physically creating the frequency. So the frequency isn't part of the function of the electron. The frequency is actually a mechanical thing you're creating, where in the process of light, the frequency is built into the electron, and in the process of radiation, the frequency is built into the electron. Yeah, that's very good, actually. Freeze this little section I just did because that's really quite brilliant. I really just explained what physics hasn't gone anywhere near that subject, and I just nailed it entirely. Yep. I mean, that's what's so great about this thing, is it just makes me, I can just turn it on. You just give me a subject and my brain will apply the proper theoretical concept and completely describe the circumstance really well. And I gave that no pre-thought. I mean, seriously. I didn't until just now really put that into articulated conceptual sentences, what I just, the idea of separating radio from light, visible light, from forms of radioactivity, radiation produced by radioactive elements. So the very fact that I just separated those three, and I just explained how they're mechanically different fundamentally in terms of the mechanism that they're exploiting to be created. And it's brilliant. It's absolutely, it's nailed it. I just fucking nailed it. Yeah. It's not exactly orgasm when that happens, but it really is kind of a nice feeling when wow, I just fucking nailed that shit. I mean, it's like a real Einstein kind of moment. Einstein would love that. He'd be like, oh, God, that's so cool. You got it, you little fucker. How the fuck did you figure that out? You goddamn cunt. I was thinking about this forever. I couldn't think of it. Fucking shit. Damn it. It's so much better than my bullshit. So anyway, so yeah, that's part of the validation. It's part of the verification process of why I must be right. Is that this way of thinking just is answering so many questions. It just fucking makes it so easy to just, yeah, I can see it. Oh yeah, I see that. It's perfectly visible. Just fantastic. Yep. So anyway, we appear to have run out of useful commentators. You're not right until you're peer reviewed. Well, obviously that's completely nonsensical and rubbish. So yeah, I'll just ignore that. That's just silly. Peer review has absolutely nothing to do with right or wrong, obviously. And obviously the peer-reviewed science that currently exists that's been accepted is wrong. So what good is peer review, right? Their standards are obviously not very high because they've had it wrong for 100 fucking years. Getting it wrong for 100 years doesn't make peer review sound like a great idea, does it? Oh, yes, they have the wrong answer for 100 years. Yes, peer review has a great record. No, that sounds like a really bad record, actually. Preposterously bad. So the last thing I want to do is get peer reviewed, right? Because only the wrong answers survive peer review. Einstein's fake lensing, for example, and you know, the whole subject of fucking quantum mechanics, the little special, magical hat of quantum mechanics. We can pull anything out of this pile of, religious kookery. Yes, so the standard will be if you want to have good science, you have to be Gary reviewed. Being Gary reviewed, and Mendham reviewed, DraftScience reviewed. Yeah, that's when you've made it. You'll be the guy with the right answers. That should be the authority. Oh, yeah, right. It's hardly sexist, but I obviously have critiqued various physics videos placed on the internet that are posing as some kind of education on the subject of physics. And quite obviously, the Physics Girl videos are sold as educational material. And obviously, I don't think it's very good education. And I think it's kind of silly in a lot of ways. Look, I'm just as horny as the next guy. She's kind of cute and fun. All right. I definitely like to bend her over, do some physics on her vagina and all that bullshit. But what should that have to do with physics, right? It's just kind of exploitation physics. And yeah, she doesn't sit there and show a bunch of cleavage or anything, but it really is just a girl being silly girly, and it's just kind of silly science. And, it's kind of puke worthy that this is called physics. Like, I mean, who is this for? You know what I mean? I mean, the subject matter obviously is way over the head of like 8th graders, but it almost seems like the content is intended, to entertain. Like, this is the kind of show you would put on between SpongeBob episodes. This it doesn't really look like it's formatted for an adult audience. It looks like it's formatted for an adolescent penis. And I just don't think adolescent penises are very good at doing physics or understanding physics or paying attention to physics or giving a shit about physics. So I just don't really see it as kind of an honest thing. I see it as just kind of a silly trivialization of the whole subject of physics. And you are free not to share my opinion, but that's my impression. And like I said, that's coming from a guy who likes that girls are doing physics. I mean, I like looking at girls. I mean, it's fun. So I'm not saying that part isn't fun, but I also think science shouldn't be done in a cartoonish manner. It kind of just degrades the the seriousness of it. To always have to put everything in a wig and do everything with jokes and everything has to be fun. Um, I'm sorry, it's just kind of insulting to our intelligence to say that we have to sugarcoat every fucking thing, and kind of pisses me off. I don't think it matters what color male you are, but whatever. I do possess a penis, and it does it does have a vote in my democracy, and I do try to stop it at the polling place, and I do try to prevent it from having too much influence, but it does sneak in and does exercise its, authority. Yeah, I mean, it really is disgusting, the whole Trump syndrome. I mean, you saw, there's these rednecks, right? They stand outside of a Democratic, whatever, one of these, whatever they are. And they sit there with their guns standing outside the plate glass windows with their guns in their pickup truck. And then you have some guy at a Trump rally today who did a whole bunch of, we're going to assassinate that bitch. We're going to kill her. And I mean, it's just like, because we're Americans. And yeah, we assassinate presidents because we're good Americans. I mean, wow. Wow. Scary bunch. That's all you got to say. And there's obviously a lot of them. Obviously, a big giant hunk of America is gone profoundly redneck. And I'm all for the, hate the fuck out of foreigners. I'm sick to death of foreigners. So I'm all for that crap. But Trump ain't going to solve that problem. And you sure as hell ain't going to solve it with no fucking wall. I mean, you got to fight for employer sanctions. They work. A good, reliable Social Security system. We need good, reliable Social Security numbers where you actually know when people are dead and you actually know where they live. And gee, that's not too government control-y, right? To have a Social Security number that identifies who you are, how old you are, what sex you are, and where the fuck you live. Oh, gee, how invasive. I don't think so. Hating foreigners isn't about hating race. It's about hating cultures. Jackass. I have a right to dislike culture. Shithead. If every black man was Sidney Poitier, racism wouldn't be an issue. And if every foreigner was pick some guy from some foreign country that makes movies, then everybody'd say fine. But that's not who they are. Well, look, you're just lying about who I am. So I've obviously said exactly the opposite, and any rational person will understand the difference between culture and race, understand the difference between somebody who speaks English and somebody who doesn't, somebody who wants to be an American, somebody who doesn't want to be an American. So you're just a liar. So fuck you. So anyway, enough and such. So I will try again next time. So yes, if you're seeing this or any part of this and you would like to participate in a live room discussion with me, comment or leave a PM to this channel informing me of your desire, and I will see that you are provided the appropriate link to the room to participate. And yes, you need to have a computer of some kind, an Android even, or something that has the capacity to produce at least an audio You know, has to have at least a microphone. You don't really have to do the camera thing, but you got to do the microphone thing and such. So, but if you're a physics person, you really should be able to handle this minor technological hurdle. Yeah, that's probably true, right? I really shouldn't have to explain to people who are going to argue physics, you know, that they have to have a working piece of technology to actually participate. Yeah, I shouldn't have to do that. Yes, I will keep endeavoring to persevere. It's my slogan. I will endeavor to continue to persevere in the manner in which I'm endeavoring to persevere, which may result in me not persevering, but I will endeavor to persevere. So, regardless of whether I do in fact persevere, I will endeavor to do so, and I will continue to endeavor. So that's the kind of guy I am. Endeavorous. I'm an endeavorite. I sort of like that. Yeah, endeavorite. Yeah. Yeah, that's what's been missing all this time. A proper label. I'm an endeavorite. Yeah, that'll inspire everyone. Everybody will want to be an endeavorite. Maybe not. Yeah, maybe that's one of those ideas when you sleep on it and you say the next day, how the fuck could I be that retarded? Whoa, was some drugs in my coffee? What the hell was wrong with me? How did I think that was a good idea? Oh my God, I'm retarded. Yeah, I bet Donald Trump has a lot of days like that. Anyway, moving on. Till next time and such. Happy, happy, merry, merry, fun, fun, such forth and whatnot.